Okay, let's get started. Thank you to everyone for attending today's webinar on SpaceClaim and how it fits into the rapid prototyping and additive manufacturing processes. My name is Sam Mark. I'm an application engineer here at SpaceClaim. Okay, so let's get down to it. So why was SpaceClaim developed? Well, we're founded by the same guys who pioneered feature-based modeling, Mike Payne and Denny Dean among them. And they recognize that there's the CAD specialists, and then there's everyone else around them, the CAD specialists, the engineers, the analysts, the engineering manager. And CAD isn't exactly their core competency, and they certainly have plenty of things to do. And the traditional CAD systems are just too hard to use, too hard to learn, so SpaceClaim was developed to address that problem. Well, how do we do it? Well, to get right down to it, it's the user interface interactions. It's simple and streamlined. It's intuitive to use. You want to change something, simply select it and pull it and move it. You don't have to struggle with feature history or a feature tree, so it's inherently more flexible when it comes down to modeling and making changes to your model. So how are customers using SpaceClaim? Well, our customers are using SpaceClaim in anywhere from manufacturing, creating fixtures, tooling, to prepping models for FEA. So for today's session, we're going to focus primarily on using SpaceClaim in prepping a model for additive manufacturing. It could be the traditional SLA, SLS prototyping process or the newer 3D printing process. Whatever the case may be, there are a number of problems that SpaceClaim can help you solve. On the right-hand side here, we have a little plastic toy model concept that I modeled in SpaceClaim. It's a fully posable robot with a lot of joints in it that took about 2 to 3 hours total modeling time. And since it's an assembly, I had to do a lot of pre-processing before I can send it out for printing. And our friends here at Solid Technologies were kind enough to print this model out for us on their Z-Corp printers. In this case, they printed this 6-inch model on their Z-Corp Z450 printer, which is one of the larger models. It took about 5 hours to print, and the actual material cost itself is about $30. Obviously, if you use more material, it's going to cost you more. If you want them to print it for you, it's going to actually cost you about $250 because there's some manual labor involved in the printing process. And here there's a couple of illustrations here to show you what they do. What's unique about these Z-Corp printers are that well, they're like any other additive process. They built the model from layer by layer, but they built it on this powder matrix that's really it's like plaster. And the print head actually prints in color, so you can see that the final product actually come out in multiple colors versus other processes. Once the model is done, they have to take it out of the powder and then do some fine depowdering, which they can then recycle and reuse. And once the model is done, they'll also have to coat it and essentially seal it with some type of resin so that it's more durable. It's a really neat process. So this is one example of additive manufacturing. So let's jump into SpaceClaim for a second and see how we can use SpaceClaim to pre-process our model for this kind of 3D printing. So I have an empty design here, and the first thing I'm going to do is I'm going to open up, actually import a couple of files. You can see that from our file type list. We're able to import a number of different file types, including major players like ATIA, ProE, SolidWorks, as well as some generic files like STEP, ACES, and Parasolid. So if you're working in a multi-CAD environment, SpaceClaim is a great tool to use. So I'm going to set to all files here, and I'm going to grab the STEP file as well as this ACES file, and I'm going to import them both at the same time. All right, now that I've my sander model in here, I want to first make sure that everything is a solid, because in order to send your model to the 3D printer, the geometry has to be completely watertight solids. And from the first glance here, I can see that I have a little problem on my hand grip. It's kind of transparent, and if I show it in the structure tree on the left-hand side, you'll see that it's actually not a solid, but a surface. it's probably coming as bad geometry. Maybe there are some gaps in the boundary, but that's not a problem because SpaceClaim has a number of powerful and automated repair tools that allows me to quickly find the problem areas and then automatically fix them. So now that I've stitched the surfaces back together, you can see that it's now a solid and the color has changed. So that's pretty fast in terms of repairing geometry. Now the other thing I'm going to look at here is this big cord that's kind of sticking out. And I really don't need this this cord to be printed out. If I'm printing a mock-up, I'll probably end up sticking a real cord on the model anyway. So I'm simply going to select it and just hit the delete key and get rid of it. And you can do this with a lot of things like internal components. If you don't need all the internal components, because if you're printing out a concept, why would you need them? And SpaceClaim would let you do it without having you to modify or redefine children components or fix missing references. It doesn't care. It just lets you do what you want and go on to do the next thing. So that's the external part of my model. So now if I want to find other problem areas, I'm going to have to look inside the model to see what's going on. So I'm going to use our cross-section mode to take a good view inside my model here. And I can scan my model for potential issues, and I can see that there's a couple of problems. One, the components on the left-hand side are completely solid, and I don't want to print out this giant block of stuff because I'm paying by the cubic inches for one, and two, it's going to be pretty heavy. So we'll address that in a moment. If we come down to the right-hand side, we'll see other issues, which is the opposite problem. Our walls here are actually kind of thin, and they might not build properly depending on the process you choose or the material you're using. So we'll have to address those somehow. Even if they build, they might just crumble in your hand if you take it out of the printer, so we'll have to thicken those somehow. Looking closer, you can also see that the dust bag is actually not attached or touching the sander's nozzle. So even if we printed it out, the parts wouldn't go together anyway, so we can't really assemble those two parts together. So we'll have to address that as well. So let's take a look at thickening the wall first, because that's probably the simplest thing to do, and that would get us partially to where we need to in terms of closing this gap. Like I said before, the power of SpaceClaim is the flexibility and the freedom you get. So if I see something that I need to change, I simply come in here and just pull on it with our pull tool. And I can enter in a particular radius for that cylinder. That's fine. And even though I'm in a cross section, I'm free to modify anything I can select. If I want to make a round in a cross section mode, that's no problem. I can actually influence 3D geometry in this 2D environment. Now, if I want to thicken this bag, I have a number of different faces that I might have to select. Instead of picking them one by one, SpaceClaim gives me the ability to find all the surfaces with the same offset. And now I can simply just grab them all and type in the thickness. So thickening those walls gives us pretty much what we need in terms of closing this gap, but there's sort of still areas that they're sort of forming an air gap or a powder gap in the case of the Z-Core printer. And we probably want to fill that in anyways, but that's not a problem because, again, we can use the pull tool to just pull the geometry to wherever we want. Just fill in those gaps. I can select a face, snap it to a different face. I can select this face over on the left-hand side, and then snap it to the end of the bag. And then simply adjust the diameter of that nozzle opening. Our goal is going to be merging all these parts into a single piece, so I don't mind them overlapping at this point, so let's consider that part done. Now we'll have to address the solid parts over on this on the left-hand side here. Well, that's not a problem either. We can simply use the shell tool and core out all the internal solid that we don't need. So it's pretty simple for that part, but if we look at the sander itself, we see that there's already a part that's in the right thickness and the rest is not. So the power of space claim allows you to split a body into multiple pieces with just a click. So now I can simply ignore this thin part here and just work on the part that I'm concerned with. I can again select the face to shell it out, removing all that solid material that I don't need. Now, here's the problem though. I have this pretty hollow thing that may or may not work in terms of structure. But the bigger problem is that I now have this this sand pad that's not really sanding pad that's not really touching the sander. So instead of just shelling out the sander, I'm going to do one thing before that. I'm going to undo, and I'm going to use our cylinder tool to make a quick cut on the inside of the sander. It's a quick way of creating geometry where you need it. So now that I have that cylindrical face, I can simply shell that out. And now I have a sander column here that the sanding pad can attach to. It also provides some more structure in terms of the model itself. So I'm going to enter in 3mm thickness, and I'm going to proceed to shell out the rest of the model here. Now I can align these cylindrical surfaces and form basically a path. The last thing I'm going to do is actually open this this part up, this part that I really don't require material. So again, using the cylinder tool, I will make another cylindrical cut. This way I can easily remove anything that's trapped inside the model. For example, the Z-Core printer's powder, for example, you can easily get all that powder out with these larger paths. So let's turn the nozzle back on here. And now it looks like I'm ready to merge all these parts together into a single piece of solid. So I'll head back to 3D mode. And simply select them all, and with a single click of the combine tool, I now have a single solid. Well, is this ready to print yet? Kind of, but I see a problem here, actually a couple of problems. One, this model is probably a little too long to print. Now if I measure the length of this model, it's about 33 centimeters. It's a little over a foot, I believe. And some printers may be able to fit it into their build envelope. Some can't. It really depends. So in our case, we're going to actually have to split this model into two parts, into two components, so they would fit inside the build envelope. The other problem is actually inside the model here. I'll go back to cross-section mode. And I can see that I have this large mass on the right-hand side that's sort of hanging out in space, and it's probably going to apply a lot of torque on this spot here. So to counter that, I'll have to add some structure on the bottom of this shell here. So I'll use again our cylinder tool here for rapid geometry creation, and simply just add one of those support posts. And I can adjust the diameter of that cylinder, certainly. Now if I flip our cross-section by 90 degrees, I can simply create a pattern of these posts all the way around the base of my sander to provide that additional support. You can see that it's snapping to places where I can make regular patterns, but I'm going to stick to 4 posts at 90 degrees. And with a quick click of the combine tool, I have incorporated that geometry into my my sander. So it provides additional support within seconds. All right, now let's address our other problem here. I'm going to have to split the bag away from the sander and probably somewhere in the middle of this cylinder here. So I'll start by creating a plane, a cutting plane. And I'll move that into place somewhere around there. Again, our friend combine tool, select the solid, and from one solid I've created two. So we started with multiple components, merged into a single solid, and now we can split it again into multiple pieces. Again, flexibility. All right, before we proceed any further, we're going to have to do some cleanup here in our structure tree. I'm going to first delete all the empty components, delete the plane that we used to cut the two parts, and let's move these parts, these solids into their own components. So now that we have a nice clean structure tree, we're going to rename these components for whatever we need them to be. And just for clarity's sake, I'm going to recolor them as well. Okay, so we have our two components. But how are we supposed to put them back together once they're done printing? I mean, I have just two flat faces here. Really, it's going to be pretty difficult to align them. But that's okay. We can come in here with our pull tool again and rapidly create a lap joint simply by offsetting the edge and pulling out that region. I can add a little bit of taper in here so it will fit into the other part easily. And I'm going to type in 3 degrees. That should be 20. Now we go back to our bag and go back into our cross section. You see that we have our lap joint, but we have to remove that geometry from the opposite side. So we'll take the combine tool and using the lap joint as a cutter, remove that overlapping geometry. We now have a nice clean lap joint that allows us to easily assemble these parts back together. Now if I need to adjust that lap joint, I can simply select it again like I did before. Select the faces you want and simply transform them. You can grab that, adjust to wherever I want. And just in case, we probably want to add some clearance here with the pull tool, just so that it would accommodate some of the tolerance variations from the printout. And if I want these two faces to mate together on the exterior, I probably want to add some clearance here as well. So again, using the pull tool, I can easily tweak the model to whatever I want. I don't have to deal with parent-child relationships. I don't have to figure out how the feature was constructed. I just see what I want to modify. I simply grab it and I modify it. And that's the power of SpaceClaim and direct modeling. So now our components are prepped and ready to be printed. So that's the end of the demonstration. So I hope this this webinar gave you a good overview of how SpaceClaim fits into the additive manufacturing process and how it can help overcome some of these issues. Maybe it be working with different file formats or fixing geometry issues or increasing wall thickness. SpaceClaim makes a lot of these modeling tasks a lot easier. Certainly makes it work faster. So it's probably time for questions. Let's see here. How do I get the model printed? Well, some of the 3D printers take SLA. Well, SLA primarily takes STL formats, and SpaceClaim can certainly export STL files. The Z-Core printer actually supports VRML files because they print in color, and VRML files contain color information. So all you have to do is do a save as. and select STL or VRML as a file format, and you can also adjust the resolution um, of the output as well, right inside Space Claim options. All right, let's see what other questions there might be here. Is there training available for Space Claim? And yes, we do have training. We have self-paced tutorials and live classes over GoToWebinar. You can find them all on at spaceclaim.com under the support menu. How long does the training take? Well, the free training over the web takes about an hour, probably 45 minutes. It's really not that difficult. I'm a pretty new user myself, so you know, it only took me a few weeks actually to even become an expert on it. Can you change the face color? Yes, you can. Going back to my model here, I can simply select a set of faces using a probably box select. This would be the easiest way to select a set of geometry and simply change that to any color I want. Let's undo that. Just make sure that you set the target to face, and you can set a subset of faces to a different color. Do you need a background in mechanical engineering to use Space Claim? No, you don't need a background in mechanical engineering if you like to use Space Claim. We offer a free trial, 30 days. Just download it, take it out for a drive, and see how you like it. It's really geared toward people who don't use traditional CAD but want to model in 3D, and you can see a lot of the interaction is really direct with the geometry. Simply select it and modify it. I mean, that's how simple it really is. How do you get into work in the section view? Well, it's simple. You can simply select an axis or a face, and then click into go to the mode section in our design tab, and simply click section mode, and it'll get you into a cross section. And you can click this little button here to move the guide in your grid guide here, and just scan through the model or double click on one of the rotational arrows to flip it 90 degrees and drop it wherever you want. Can you put a radius on a native STL file? We allows you to open STL files, but unfortunately there's limited interaction with lightweight facets, which are what STL files are going to come in as. So what you have to do probably is to build your model around the STL file, and we allow you to reference the STL faces and facets when you're pulling things or moving things. You can actually snap your geometry to the facets. Does the program work as easily if you're starting with the STL file? Well, again, if we import an STL file, we allow you to build around it, and certainly creating geometry in Space Claim is just as easy. You simply start by tracing your STL file, and then again push and pull to get what you need to do. Really, everything is based on these four major tools: pull, move, fill, and combine. And we only use 3 of them in our demonstration today. All right, I think that's all the time we have for today. Thank you, everybody, for coming.